Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. I don't know what the title is. It might be 17.3 or Unit 6, Lesson 4. I don't know. It depends on what class you're in, and it depends on how I title the video. But what I do know are what our two goals are. And our first goal is going to be to investigate rotations on the coordinate plane. And our second goal is going to be to create rules for rotating 90 degrees, 180 degrees, 270 degrees, negative 90 degrees, 180 degrees, and negative 270 degrees. So let's go ahead and jump into our first goal here of investigating rotations on the coordinate plane. Now I don't have a coordinate plane yet, but I just want to review a little bit of rotations. So a rotation is the spinning of an object. The object will rotate about a point. Here's an example. Triangle ABC is going to be rotating about point R. I know that this is my pre-image because there's no prime mark, so this is my pre-image. And I know that it spins to get to here, which is my image, because I have the prime marks, right? And so I want to talk a little bit about what happens when we're rotating. So as the figure rotates, the points maintain their distances to point R. So as I go from this location and I rotate to this location, the length from A to R is going to be the same as A prime to R. The length from B to R is going to be the same as B prime to R, and the length of C to R will be the same as C prime to R. Lengths will be, respected. This will be supported by arcs connecting A to A prime, B to B prime, and C to C prime. So what I want to do, hopefully I drew this well enough, is I'd like to draw an arc, which is part of a circle, centered at point R from A to A prime, and then B to B prime, and then C to C prime. And you'll see that if I drew this correctly, the arc will hit point A and A prime, and point A prime, and that shows that they're the same distance apart. Remember, circles have equal radius, and when you draw a circle and it hits 2 points, that means the points are the same distance from the center. So let's see if I did this correctly. This is going to be exciting here. I'm going to use my compass, which are used to make circles. So I make an arc. So this shows me that these points are the same distance away. If I make another arc, see how I do on this guy. Oh, it's close. So that shows me that these points are the same distance away from point R. And if I make a third arc, oh, there goes the lid. A lot of pressure. And it's there. So we can see that this is rotating in this direction, right? And it's a little hard to understand how this spins. So hopefully seeing the arc centered at point R helps you to understand how this shape spins. Now, it also makes sense that this arc is shorter in length than this arc, and this arc is shorter in length than this arc, and then all one has to do is think about the orbits of the planets. The planet that's closest to the sun doesn't have to travel as far around the sun to make an orbit, while the planet that's farthest from the sun has to travel a lot farther to make it all the way around the sun for a full orbit. So I'm going to go ahead and erase all this. I'm going to come back and start talking about rotations on the coordinate planes, which are going to allow me to segue into my second goal. So let me clear everything off and I'll be back. I'm back. I didn't erase everything there. I wanted to add one more thing to this first part of the lesson that I left out, but I think it's really important. And this is what I want to add. One more thing. Angle AR A prime is congruent to, which is the same size, same shape, angle BR B prime, and that's congruent to angle CR C prime. So the angles made by connecting these points will all be the same. So let me quickly go through that. I just want to show you this, that everybody is moving at the same amount. And when we're talking about a rotation, we're talking about how much it moves in terms of an angle. So I want to just plant that seed before we move on. So I'll show you that angle AR A prime should roughly be a right angle, which is what I tried to do when I did this lesson. So I wanted this angle to be as close to a 90-degree angle as possible. So you can see that this is roughly 90 degrees. And if I erase this here or leave it, I don't know, it's going to get crowded. I'm on the fence of what I should do. I'll put another color up here. If I draw angle BRB prime in green, I'm also going to get an angle that's roughly 90 degrees. So when we're rotating shapes, all the points in the shape, they move at the same amount. Let me erase this, just so you can see it a little bit better. So you can see that the angle made by connecting point B, R, and B prime, again, that's roughly 90 degrees. And the same thing would be true if I connected points C, R, and C prime. So I'll do that as well. So when we're rotating, again, we're talking about how much everybody moves by an angle amount. So I just wanted to really reinforce that before I move forward. And we'll see, hopefully, that this one is as well close to a 90-degree angle. Okay. So again, we can see that that is very close to a 90-degree angle. And again, that reinforces that they're all moving at the same amount. So I'm going to go ahead and hit pause, erase everything, come back and talk a little bit about rotations on the coordinate plane, and we will continue with this lesson. So I'll be back. I'm back. So let's continue with our first goal. This first goal is actually going to be pretty long-winded. I apologize for that. So I'm going to try and move through it as smoothly and as effectively as possible. All right, so let's review the coordinate plane and their quadrants. It's called quadrants because it's broken up into four. We call this our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. And we count the quadrants in a counterclockwise direction. So we go in this direction. This is the positive direction of mathematics. Okay, and the coordinate plane reminds us of that. This is a positive direction. The clockwise direction, going like a clock, is the negative direction. So it's very important that we can differentiate which way is a positive rotation and which way is a negative rotation. And if you forget, just remember the way the quadrants go, and that's a positive direction. So I have a question here. What is a 90-degree rotation? It is rotating all the points into the next quadrant about the origin in a counterclockwise direction. Remember, we have to have a point that we're rotating about. So in the previous section, we were rotating about R. For this lesson, we'll be rotating about the origin. The origin is right there. So, example 1, all the points in quadrant 1 would rotate to quadrant 2. So, again, it's just going to spin into the next quadrant about the origin. The example 2, all the points in quadrant 4 would rotate into quadrant 1. Remember, we're going in a counterclockwise direction, so it would rotate up to that. So I'm going to go ahead and hit pause, come back, talk about what it looks like to be a 180-degree rotation, what it looks like to be a 270-degree rotation. And so let me clean this up, and I will be back. I'm back again. I don't know how many more times I'm going to be back, hopefully just one more time. But here we are, we're going to finish our first goal. Now I have a picture of our coordinate plane with the quadrants. Remember, we count in a positive direction and we go in a counterclockwise direction, and we count in a negative direction and we go in the clockwise direction. So I have just two more scenarios here. What is a 180-degree rotation? It is rotating all the points to a quadrant that is 2 quadrants away from the original in a counterclockwise direction. Remember, this is positive and counterclockwise is positive. So example 1, all the points in quadrant 1 would rotate to quadrant 3. So they would all the points in here would rotate to quadrant 3. Now I am leaving something out about the angle that they make when we rotate. They make a 180-degree angle. With the previous example of the 90-degree question, they make a 90-degree angle, just like that first scenario we had. So these are going to make a straight line when you rotate them. So all the points in quadrant 1 would rotate to quadrant 3, because that's 2 quadrants away in the counterclockwise direction. all the points in quadrant 4 would rotate 2 quadrants away in the counterclockwise direction, and we would end up in quadrant 2. Again, if you were to draw a line from the pre-image to the image, it would make a straight line. That's what a 180-degree angle is. Okay. What is a 270-degree rotation? It is rotating all the points to a quadrant that is 3 quadrants away from the original in a counterclockwise direction. All the points in quadrant 1 would rotate to quadrant 4. So if I wanted to do a 270-degree rotation, I would rotate all the way around here, and I would get to here. Okay. Another example would be all the points in quadrant 4 would rotate 270 degrees to quadrant 3. Now, look, quadrant 4 in the counterclockwise is 3 away from quadrant 3. However, in the clockwise direction, it is 90 degrees away, right? Or negative 90 degrees. So it's 1 quadrant away. So 270-degree rotation is a negative 90-degree rotation. Okay? So 270-degree rotation is a negative 90-degree rotation. We both end up in the same location. And if we look at 180-degree rotation, for example, we start in quadrant 4 and we rotate in the counterclockwise direction, we end up in quadrant 2. But if we also rotate in the clockwise direction, 2 quadrants, we end up in quadrant 2 as well. So a 180-degree rotation is the same as a negative 180-degree rotation. So 180-degree rotation is the same as a negative 180-degree rotation. Okay? Oh, I'm going to run out of room here, but that's okay. Alright, so hopefully I can finish this all in one more take. We'll see. And by the way, a 90-degree rotation is the same as a negative 270-degree rotation. I'll note that in the next section. So let me clean off everything. We'll actually look at specific examples. We'll see what the 90-degree rotation actually looks like, the 180-degree rotation, and the 270-degree rotation. So let me clear this off, and I will be back. I'm back again. I keep coming back. This is a lot of comebacks. Come back, kid. Anyways, we're into our second goal. We're going to create rules for rotating 90 degrees, which is the same as rotating negative 270, and I'll explain a little bit more later on. 180 degrees, which is also the same as negative 180 degrees, or 270 degrees, which also is the same as negative 90 degrees. I only have 2 examples left, so I'm going to have to come back one more time. I promise it'll be the last time. All right? So I'm going to create a rule for a 90 degree or 270 degree rotation about the origin. So what I want to do is I want to draw a line to the origin and then make a right angle off of that. And then I'm going to take my compass and I'm just going to make a little circle, and where my little circle crosses the side of the right angle, that's where its image is going to be for each point. So I'm going to, in a sense, build a rotation, and then from there, hopefully we get the correct point values. This is drawn by hand, so it's going to be off a little bit. I apologize that I'm not actually constructing right angles here, but let's just go through this step by step. All right, so from 2-1, I'm going to draw a line to the origin, and I'm going to draw what I believe to be a right angle off of that. Okay. So I have a little right angle coming off of this. Remember, I'm rotating in the counterclockwise direction at 90 degrees. And so if I take a little compass and I can make a mark or make a little arc that represents the distance from my point to the point we're rotating about, you'll see that, oh, let me do better than this. You'll see that my image point is right here. So let me erase that. erase this. It's going to get a little messy, but what's important is the result, okay? So I found C prime by rotating 90 degrees. I'm going to do the same for B, and I'll do the same for A. I do apologize. I've never done this method before, and I'm kind of curious to see how it works out on a video. So let me do the B in green. Again, I'll draw off of a line to the origin. And I'm going to draw a side so I get a right angle off of that. Okay. So I made a right angle, indicating that I'm going to rotate this point 90 degrees. Now I just need to find where on that point is. And so I'm going to use my compass again to do that. And so this is where the point rotates to. All right, let me erase all this. And I got one more point that I need to find, and that's my point C. And let's see here. Or not my point C. I already found point C prime, and I already found B prime. I need to find A prime. So like before, I'll just draw a line to the origin and make a right angle off of that. See, that looks to be about a right angle. All right. Oh no, that needs to be more like that. Okay, that looks like more of a right angle. Okay, so I got my right angle indicating I'm going to rotate this point in this direction. And now again, I just need to find my point by using my compass, which I hit over here. And there's my point that I rotate to. All right, so let me clean this up. Again, I apologize, it's a little busy here. But I just wanted to show you what a 90-degree rotation actually looked like geometrically. I'll just erase all of that and clean that up. Okay, give me 1 second here. There's my C at a value of 2, 1. C prime, which is here now, let me make that better. C prime is -1, 2. B prime is -2, 5. And A prime is -4, 3. Oh, it should be down just a little bit. Again, it's hand drawn. It's going to be off a little bit. So again, I apologize. A prime is -4, 3. So we connect these dots. We'll see that we've actually, in fact, rotated the triangle 90 degrees. And it's hand drawn. This drives me nuts that it's not exact, but we're gonna just have to pretend in this world that it's okay. So let's list the points or list the mapping. So A, which is 3, 4, maps to A prime, which is -4, 3. B, which is 5, 2, maps to B prime, which is -2, 5. And C, which is 2, 1, maps to C prime, which is -1, 2. So in looking at the pattern of what's happening from the pre-image to the image, we can see that the order of the numbers changes, and not only that, the sign of the first number changes. So the rule for rotating 90 degrees or negative 270 degrees, because I would go 3 quadrants in the clockwise direction. That's why it's negative 270, or 1 quadrant in the counterclockwise. So the rule for rotating 90 degrees or negative 270 degrees is going to be xy maps to negative y x. So the order switches and the y changes signs. I really hope that this concept is translating over this video. I've never taught it in this way before, and I was thinking about how I could teach it in such a way that it would make a little bit more sense. So, and I do apologize, this again is another long lesson that we're going to be watching. So, my ruler that I hid for myself is right there. All right, so let's create a rule for 180 degrees or negative 180 degrees. This one's a little easier to make because I don't have to draw a right angle. I'll just draw a straight line, figure out how far that point was, and then I get my primes a little bit easier. So let's see here. Going through the origin. For my C, I go like that. Okay, let me find how far away it is. Okay, so it is that far away, which is so off. That's so off. Let me try that again. Okay. Maybe I numbered it too bad. That might be, the numbering might be off. I can actually see that. All right. The numbering is actually off. I'm going to fudge the circle because the numbering is way off. All right, so that's where it's going to rotate to. Okay, so that would be 180 degrees in the counterclockwise or in the clockwise. So that's where C prime ends up. Okay, so C prime ends up at C prime ends up at -2, -1. Okay, and I'll rewrite that point here in a second. B, again, we're going to draw the line through. With B and green, I guess I'll do the same over here. Alright. And again, if I was to make the arc, I don't have to go all the way around. I could actually shorten it a little bit. Just do this. Okay, that copies the distance. So there's my B prime right there. We'll erase everything else. Okay, there's B prime. And B prime has a value of -5, -2. And let's find A prime. I already did that. I'll do blue, I guess. Okay, let's find A. And again, I'm drawing a 180-degree angle here. That's what I'm doing. So what it looks like is the order of the points are switching and the signs are changing. So hopefully that works for A prime in this terribly drawn graph that I drew. Hand-drawn graph. I should have taken the time to draw it even more accurate. Mental note, next time you do this, do that. Looks okay. And again, what I was doing was I was making the same distance on the other side without drawing the whole circle. All right, there is my A prime, which is -3, negative. Oh, it should have been down a little lower. We'll fudge that. A prime, -3, -4. Okay, and if I connect the dots, I should get the same triangle that has been rotated 180 degrees. Let me fill this back in. C is 2, 1. Okay. So you can see that I rotated it 180 degrees. Let's list the mapping. Okay, A, which is 3, 4, goes to A prime, which is -3, -4. B, which is 5, 2, goes to B prime, which is -5, -2, and C, which is 2, 1, goes to -2, -1. And so what it looks like is the numbers stay in the same order, but the signs are changing. So the rule for rotating 2 quadrants counterclockwise or 2 quadrants clockwise 180 degrees or -180 degrees, rotation about the origin. The rule for rotating -180 degrees or -180 degrees is XY maps to -x, -y. So we just changed the signs. All right. I'm not sure if I like this list or not. Hopefully it translates to you guys. I still have one more example to do. I'm going to try and draw a better graph. So let me clean this up, and then we'll talk about creating a rule for a 270 degree rotation or a -90 degree rotation. And that should clarify all the rules. So let me clean this up, and I'll be back for the last time. I absolutely promise. I'm back for the last time. I absolutely promise. I want to be done with this lesson. I'm sure you guys do too. So I'm going to do what I did on the previous one. I tried to make a more accurate coordinate plane, but let's just go ahead and make sure we understand what we're going to try and do here. We're going to try to create a rule for rotating 270 degrees or -90 degrees about the origin. A 270 degree rotation would rotate the triangle to quadrant 4. Remember, we go 3 quadrants in the counterclockwise direction, and we would end up in quadrant 4. So would a -90 degree rotation in the clockwise direction. So a 90 degree means we go to the next one. -90 means we're moving in a clockwise direction. We'll go in the clockwise direction because it's a lot easier to draw a 90 degree angle than a 270 degree angle. So let's go ahead and start moving everybody. So I'm going to draw a line to the origin because that's who we're rotating about. And I'm going to make a -90 degree angle because we're going in the clockwise direction. Okay. And now I'm just going to make sure I have the same distances here. So there's my C prime. Write that out, C prime. Oh, well, actually, I'll wait till we're done with everybody. So there's my C prime. Okay, let's do B. Now let's find out where B goes to with a -90 rotation. -90 degree rotation. So draw a line to my origin. Now you guys are not going to have to draw lines and do this. I'm doing this so we can see how the formula is created. I like to know why things work. If I know why things work, I tend to make it easier for me to work with. All right, so let me rotate this guy. I hope my compass is long enough to rotate it. All right, it's close. Okay. All right, so this is where B prime is. That's where it would rotate to. I always wonder why my fingers are so dirty, my hands are so dirty at the end of the day of talking to myself in front of my camera. We got one more to go. Let's do red. Red, red, red. All right, there we go. Again, we're going to draw our line. And we're going to make a 90-degree angle off of that. If I was doing this properly, I would actually be constructing the 90-degree angle. But then this video that's this long right now would be much longer later. So just for the sake of sanity for you, for me, let's keep it a little bit shorter. Where did I hide my... Oh, I hid it right there. Like a parrot. All right. So let's rotate this. All right, and that's where my A prime is. So let me clean this up a little bit, label them, and then we'll pay attention to the mapping, and then create our last rule, and be done with this lesson. Done with you. All right, so let's connect these dots and label these points. So you can go into there, like that, and like that. C prime looks to be at 1, -2. A prime looks to be at 4, -3. And C prime looks to be at, B prime looks to be at 2, -5. So let's look at the mapping and figure out a rule for either a 270-degree counterclockwise rotation or a -90-degree clockwise rotation. So let's look at the mapping. So A, which is 3, 4, maps to A prime, which is -4, 3, and B, which is 5, 2, maps to B prime, which is 2, -5, and C, which is 2, 1, maps to C prime, which is 1, -2. So it looks like the order is switching. All right, so the order switches and the sign of what was the X changes. So the rule for 270-degree or -90-degree rotations is XY maps to Y, -X. So they switch. I can't spell. They switch and the X value changes sign. This was a long lesson. I do apologize. I really hope that you understand what I did. I'm so sorry for how long it was. hopefully the concepts make sense. I wanted you to see how the rules were created, and I hope that I didn't make the lesson too long and too hard to follow. But again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.